Hi everyone, my name is Dr. Alexandre Reeberg de Mello, and this poster is about using Explainable Boosting Classifier for malware detection and the local explainability of each file. A pertinent threat in cybersecurity is the malware, or malicious software, that targets systems to hijack data and credentials that allow remote code execution. Recently, researchers and companies are increasing efforts on systems protection by identifying malware before its execution. We propose using explainable AI to identify malware in portable executable file and to understand the prediction decision by listing the features that most contributes to each module decision. We train an explainable boosting classifier, which is a generalized additive model from Interpret ML on 2000 files. To each file from the test set that we want to investigate, we can use the local explanation to check the most relevant features given a prediction. The lack of explainability from the black box models increases the challenge of understanding why a model fails on classifying certain files and does not provide precise information regarding the model's decision making. The machine learning pipeline to train and evaluate our explainable boosting classifier model starts with the data collection. We collect 20,000 portable executable file, or roughly 53.4 gigabytes, in the EXE and DLL formats from January to March 2022, where 14,000 files are malware and 14 are trusted. We acquired the malware from the malware based repository and the debugging from randomly select trusted sources. To avoid data leakage during tests, the first 10,000 files acquired from each class are used in the training set, and the newest 4,000 files are the test set. To provide reproducibility, the hash functions of all files are available in our GitHub repository. After acquiring the necessary data, we disassemble and parse all files using the Leaf library to create 4,209 features that represent different characteristics of each file, such as section size, entropy, presence of certain strings, and many others. We split the training set in a 70-30% ratio to optimize the hyperparameters, and we evaluate the results on the test set. We achieve an accuracy and weighted average of 97% in the classification process. For the binding files, we achieve a precision of 1, recall of 97%, and F1 score of 0.98. And for the malware, a precision 80%, recall of 98%, and F1 of 89%. The results shows that the model performs better in identifying trusted files, which decrease the number of false positives for the user. However, the model still needs the improvement in identifying malware. For the misclassified files, we use the Explainable Boosting Classifier local explanation to provide valuable information on what features to observe on each PE file given the purpose of the software. The goal is analyzing the local explanation to check how the most relevant features can relate to unusual code sections or characteristics, obfuscation, or compare the local explanation on different versions of the same software to check for unusual content. In order to improve the Explainable Boosting Classifier model performance on identifying malware, we are currently working on feature engineering and selection and evaluating an ensemble classifiers composed of Explainable Boosting Classifier models and other non-glass box tree-based models. There are challenges regarding the usage of local and global explanations in the cybersecurity context. The explanation analysis is time-consuming and requires a cybersecurity specialist. There are multiple possible explanations for the local and global features, most relevant features to a model. For example, a binding file may have a similar behavior to a malware as a file encryptor software, or the file may have the wrong label, or the model may be over or underfitting. Overall, knowing the most relevant features given a prediction provides valuable hints on where to look in a file to confirm if it's a malware or a trusted file, to indicate the malware family, or to understand the file behavior. Thank you.